Hello, welcome back. In this video, we're going to find one-sided limits for 3 different cases. Before I hit the road, I just want to remind you that you can use your TI-84 to graphically see what the limit values could be for these different functions. Like in the first example, the limit of the rational function x over x minus 2 as x approaches 2 from the right is being asked. So all you can do is you can punch in y1 equals x over x minus 2, and you can choose your x min to be 1.9, x max to be 2.1. But since you're approaching 2 from the right, it's better to pick x min and x max to be like 201 and let's say 2.1. And in the next step, you can slightly decrease the x min to 2.001. And in the next step, 2.0001, and see what the function values look like. And this way you can guess the limit value. But now we're going to do it algebraically and readily. So if you are on the right of 2, you're talking about x's, which are in the form of 2.0001, 2.00001. Okay? So once you plug in those numbers in here, the top is, well, 2.00 something, but the bottom is that number minus 2. So it's going to be what? 2.00 something minus 2 is going to be 0.00000 whatever, right? So then the top is still 2.000, right? So that number divided by a very small number is going to approach infinity because it's going to increase without a bound. That's what means for the limit to be infinity. Okay, so I'm going to go ahead and write here infinity. And in the next example, we're approaching 0 from the left. So we're talking about negative numbers, but very close to 0. What we can do is just we can plug negative 0.00001. Well, first off, this number is going to be negative. 1 over that number is going to be negative. But every time you get closer to 0 from the left, so that means you're adding more decimal places like zeros to the number. So this number gets arbitrarily large, and then this one has no role in it because it's going to be a very big negative number. And we can easily conclude that the function values are decreasing without a bound. So this limit should be minus infinity. Okay, let me just write it here. Is minus infinity. And for part C, we are looking at the limit of x squared plus 2 over x plus 4 as x approaches negative 4 from the left. So we're thinking about numbers like negative 4.000 something. When you plug that number into this rational expression, it's going to be 4 plus that number, but it's going to be a negative number, but very close to 0. So negative 0.000 something, and you're dividing 2 by that number, so you will see that for 2 over x plus 4, the values decrease without a bound, so this tends to negative infinity. Now let's check what's going on with this x squared term. Well, if you get closer to negative 4, x squared is a continuous function. We can perfectly plug in negative 4 here just to see the behavior. So it's going to be negative 4 quantity squared, that's 16. Well, you have 16 minus infinity. Infinity is a very large number. So then everything is going to approach minus infinity because this minus infinity is going to govern the behavior of the full function. All right, this is the end of the video. I'll see you in another video. Bye.